method. So we're given 4 pairs of linear equations, and for each pair we have to solve it using both elimination as well as substitution. So let's start with the first part. So the first part is x plus y equal to 5 and 2x minus 3y equal to 4. So let's first do this using elimination. So we have x plus y equal to 5 and we have 2x minus 3y equal to 4. So what I will do is I will make the coefficient of x in the first part equal to 2 so that the coefficients of x in both the equations match. So I can do that by multiplying the first equation by 2, and if I do that I get this modified equation 2x plus 2y is equal to 10. So now I have these two equations, so let's call this 1 and let's call this 2. And now by doing 2 minus 1, so subtracting equation 1 from equation 2, what do I get on the LHS? So on the LHS, the 2x and 2x will cancel out and I will be left with 2y minus 3y. So 2y minus 3y on the LHS, and on the RHS I will get 10 minus 4. 10 minus 4. So this gives me 5y is equal to 6, or y is equal to 6 by 5. And now because y is equal to 6 by 5, now I can find x using any of these two equations. So let's use x plus y equal to 5. So x should be equal to 5 minus y, or 5 minus 6 by 5, and this is equal to 25 minus 6, or 19 by 5. So x is equal to 19 by 5 and y is equal to 6 by 5. Okay, now let's solve the same pair of equations using substitution. So again, the pair of equations is x plus y equal to 5 and 2x minus 3y is equal to 4. So from the first equation, let me write x in terms of y. So x can be written as 5 minus y, and let me substitute this value of x into the second equation. So the second equation is 2x, or 2 times 5 minus y, so 2 times 5 minus y, minus 3y is equal to 4. Now this is an equation in y alone, so let's solve it to find the value of y. So we get 2 into 5 minus y, or 10 minus 2y, minus 3y is equal to 4, or 10 minus 5y is equal to 4, or 5y, so I can isolate 5y is equal to 6, or y is equal to 6 by 5. So once again I get the same value as I get in the first using elimination, and once I have y equal to 6 by 5, I can substitute this into x is equal to 5 minus y. So x will be equal to 19 by 5 once again, 19 by 5. So the answer to this pair of equations, the solution is x is equal to 19 by 5 and y is equal to 6 by 5. Okay, the second pair of equations is 3x plus 4y equal to 10 and 2x minus 2y equal to 2. So let's first solve this pair using elimination. So we have 3x plus 4y equal to 10 and 2x minus 2y is equal to 2. So now we can see that the coefficient of y is 4 in the first equation and minus 2 in the second equation. So I can modify the second equation so that the numerical magnitude of the coefficient of y is the same in both equations. So if I multiply the second equation by 2 on both sides, this minus 2 will turn into minus 4, and then I can add the two equations. So let's do that. So if I multiply the second equation by 2, I will get 4x minus 4y is equal to 4. So now I have these two equations. So let's call this first equation 1 and let's call this modified second equation 2. And now if I do 1 plus 2, this 4y and minus 4y will cancel out, and on the left side I will have 3x plus 4x, so that's 3x plus 4x on the left side, and on the right side I will have 10 and 4, so 10 plus 4, and this gives me 7x is equal to 14, or x is equal to 14 by 7 or 2. So once I get x, I can find the value of y by substituting the value of x in any of the two equations. So let's do that in the first equation. So 3x, which is equal to 6, plus 4y is equal to 10, which means that 4y is equal to 10 minus 6 or 4, or y is equal to 1. So the answer to this pair of equations, the solution is x is equal to 2 and y is equal to 1. Now let's arrive at the same answer using substitution. So in substitution, what we can do is take any of the equations and find one of the variables in terms of the other. So let me take the second equation, 2x minus 2y is equal to 2, and write x in terms of y. So 2x is equal to 2y plus 2, and from here I can write x is equal to 2y plus 2 divided by 2, or y plus 1. So x is equal to y plus 1, and now I can substitute this into the second equation. So the first equation. So the first equation is 3x plus 4y is equal to 10. So here I will substitute, instead of x I can write y plus 1. So 3 times y plus 1, so this is the substitution I'm doing, plus 4y, this is equal to 10. Now let's expand this. So we get 3y plus 3 plus 4y is equal to 10, or on the left side I get 7y, 3y plus 4y is 7y, and I can take this 3 on the right, and that gives me 7y equal to 7, or y is equal to 1. And because y is equal to 1 and x is equal to y plus 1, from here I can write x is equal to 2. So once again we arrive at the same answer, x is equal to 2 and y is equal to 1. This is the solution of this pair of equations. In the third part, the pair of equations is 3x minus 5y minus 4 equal to 0 and 9x equal to 2y plus 7. So let's first solve this pair using elimination. So the first equation is 3x minus 5y minus 4 is equal to 0, and the second equation is 9x equal to 2y plus 7. So let's bring the RHS terms on the LHS to write it in the standard form. So 9x minus 2y minus 7 is equal to 0. So this is the pair of equations, and we can see that the coefficient of x in the first equation is 3 and in the second equation is 9. So I can modify the first equation so that the coefficients of x match in the two equations, and I can do that by multiplying the first equation by 3, because that will turn 3x into 9x. So let's do that. So once I do that, once I multiply the first equation by 3, I will get 9x minus 15y minus 12 is equal to 0. And now all I have to do is I have to subtract these two equations, and that will eliminate x and enable us to find the value of y. So let's call this equation 1 and let's call this equation 2. So what we can do now is 1 minus 2. So by doing this, what do we get? So we get minus 2y minus 15y. So minus 2y, and this becomes plus because of the double negative sign. So minus 2y plus 15y, and then minus 7, and then minus 12 or plus 12. This is equal to 0. So this gives me minus 2y plus 15y is 13y. 13y and minus 7 plus 12 is 5. So 13y plus 5 is equal to 0, or y is equal to minus 5 by 13. So this is the value of y, and now let's find the value of x using this. So by substituting this value of y minus 5 by 13 into the first equation, I can find the value of x. So we have 3x minus 5y. So minus 5y will be 25 by 13 minus 4 is equal to 0, and this will give me 3x, and 25 by 13 minus 4 is minus 27 by 13. So I can take it to the right side. So that's 27 by 13. So 3x is equal to 27 by 13, or x is equal to 9 by 13. So the solution to this pair of equations is x is equal to 9 by 13 and y is equal to minus 5 by 13. Let's see if we get the same answer using substitution now. So in substitution, let me take the second equation and write x in terms of y. So we have the second equation as 9x equal to 2y plus 7, and from here I can write x is equal to 2y plus 7 by 9. And now let's substitute this value of x into the first equation. So the first equation is 3x minus 5y minus 4 equal to 0. So instead of x, let's write this expression in y, 2y plus 7 by 9. So we have 2y plus 7 by 9, and then we have minus 5y minus 4. This is equal to 0. So now let's simplify this. So 3 and this 9 cancel to give 3. So 2y plus 7 by 3, this is equal to, so I can take these two terms on the right side. So this is equal to 5y plus 4, and now let's cross multiply this 3. So I will get 2y plus 7 is equal to 15y plus 12, and finally let me take this 2y to the right side, subtract it from 15y, so that's 13y, and this 2 on this side subtracted from 7, so 13y is equal to 5, or y is equal to 5 by 13. So now this is an equation in y alone. So let's simplify it and find the value of y. So we have 3 times 3 is 9. So the first term becomes 2y plus 7 by 3. And these two terms minus 5y minus 4, let me take them to the RHS and write them as 5y plus 4. And now let's cross multiply 3 on the right side, and that will give me 2y plus 7 is equal to 15y plus 12. And now let's take this 2y to the right side, subtract it from 15y, so that's 13y, and then we have 12 subtracted from 7, so that's minus 5. So 13y is equal to minus 5, or y is equal to minus 5 by 13. So this is exactly the same value that we got using elimination. And now using this value of y, we can substitute this into any of the two equations. We can substitute this into this expression for x, and we will get the value of x as 9 by 13 once again. So the answer to this, the solution to this pair of equations is x is equal to 9 by 13 and y is equal to minus 5 by 13. In the fourth part, the pair of equations is x by 2 plus 2y by 3 equal to minus 1, and x minus y by 3 is equal to 3. So let's first solve this pair using elimination. So the two equations are x by 2 plus 2y by 3 is equal to minus 1, and x minus y by 3 is equal to 3. Now we can eliminate both either of the two variables, x or y. So the coefficient of x in the first equation is half and in the second equation is 1. So if I multiply the first equation by 2, I can match the coefficients of x and then eliminate x. I could also eliminate y because the coefficient of y in the first equation is 2 by 3 and in the second equation is minus 1 by 3. So I could multiply the second equation by 2 and then add the two equations to eliminate y. So I can choose either of the two. So let me choose to eliminate x. So to do that, I will multiply the first equation by 2 on both sides and write this equation as x plus 4y by 3 is equal to minus 2. So now I have this equation, let's call it 1, and this modified form of the first equation, let's call it 2, and now I can simply do 2 minus 1. So by doing this 2 minus 1, I will eliminate x, and on the LHS I will get 4y by 3 minus, and this minus y by 3, so minus y by 3 on the left side, and on the right side I will have minus 2 minus 3. So this is what we get. So 4y by 3 plus minus y by 3 is plus y by 3, so that's 5y by 3 on the LHS, and on the RHS we have minus 5, and this gives us y equal to minus 3. So y is equal to minus 3, and now from any of the two equations we can find the value of x. So let's substitute the value of y in this equation. So x should be equal to y by 3 plus 3. So because y is minus 3, y by 3 is minus 1. So minus 1 plus 3 is minus 2. So the solution to this pair is x is equal to minus 2 and y is equal to minus 3. Now let's check if we will get the same values using substitution. So in substitution, let me take the second equation and write x in terms of y. So x is equal to y by 3 plus 3. So this is from the second equation. Now let's substitute this value of x into the first equation. So the first equation is x by 2 plus 2y by 3 equal to minus 1. So instead of x, let me write y by 3 plus 3, this expression in y. So y by 3 plus 3, and then we have plus 2y by 3 is equal to minus 1. Now this is an equation in y alone, so let's solve it to find the value of y. So y by 3 plus 3 by 2, this first term can be written as y by 6 plus 3 by 2, and then we have this 2y by 3, this is equal to minus 1. So if I now add y by 6 and 2y by 3, so let's make the LCM equal. So 2y by 3 can be written as 4y by 6, that plus y by 6 is 5y by 6, and then I can take this 3 by 2 to the right side. So minus 1 minus 3 by 2 is minus 5 by 2, and from here if I isolate y, I will get y is equal to minus 5 by 2 into 6 by 5, and this is equal to minus 3 once again. So y is equal to minus 3, and this matches what we got from elimination. And once we have the value of y, we can substitute it into this expression for x in terms of y, and we will get x as minus 2 again. So the solution to this pair of equations is x is equal to minus 2 and y is equal to minus 3.